Continuing lesson 7.4, finding areas of polygons. So again, we're just trying to look at polygons, potentially break them up into different figures that we know how to find the area of, and then add those areas together is the way we'll do these a lot of times. So number 5 here, the do you know how. We've got a polygon. They're giving us the coordinates, and they want us to find the area of this. So refreshing our memory a little bit here, if we have coordinates like this, it's alphabetical order. The first coordinate is the x, the second coordinate is the y. They didn't have to do this for us. It will not always be there for you, but they did label this time. And again, a way to remember it, the x goes across, kind of like if we take an x and turn it, then it kind of looks like a cross. Okay, so if we go first of all just to graph these points, so 6, 2, we go over 6, up 2, 9, 5, and they're going to give you these actually in order. So we'll just connect from the first point to that point, and then 12, 2, 12, negative 4, and 6, negative 4. Okay, yeah, so we got kind of a home plate looking thing here. So again, we don't necessarily have a formula for finding the area of that, but we can break it up into smaller pieces potentially and find those areas and add them together. So for this particular problem, if we draw a horizontal line here, we could split this up into a triangle, and a rectangle actually is a square specifically. And then we could find those areas and add those together. On our triangle, we can go back with our reference sheet. We had a formula for the area of a triangle was 1/2 times the base times the height. So we can just count along the base. So going along the bottom of our triangle here, we can just count how many squares that is going across, which would be 6. And then the height of the triangle is just going straight up and down here, and we can see that that goes by 3 squares. So it's been a little bit since we've done this maybe, but we could, if you wanted to, 6 is even, so half of 6 we could do first, which would be 3, and then 3 times 3 is 9. Would be our triangle. Square is going to be pretty simple. Square is a type of rectangle, so we just do length times width. So going across, we already said we had 6 squares. Going up and down, if we count that, would be 6 squares as well. So 6 times 6 is 36. And then as our final step, we can just add those together. So 9 plus 36, or 36 plus 9, would be 45. It's an area, so we'd say 45 square units would be our area. So look at workbook page 99. We are going to do number 3 to start off with. So we've got what looks like a T. So we don't really have a formula for this. So again, we could break this up into different pieces and then figure out what our total area is. So this could be split up into a couple of rectangles. If we just split it horizontally here, it's probably going to be a good approach for us to take. So first step, find the area of our first rectangle. Area of a rectangle, again, we do length times width. We can see on our first rectangle dimensions are 12 and 3. So we'll multiply those together. So 12 times 3 is 36. So 36 square centimeters would be the area for our first rectangle. The second rectangle, if we look at that, I can clearly see one of the dimensions there is 9. The question is what our other dimension is, and we got to think this out a little bit.
Looks like it could be.
So our other dimension, if we look at this, they've got 4 centimeters with arrows 2 different spots. So this is 4 centimeters here, this is 4 centimeters. If you notice at the top, we've got 12 centimeters. That's going all the way across. So we've got 4 and 4 already taken care of is 8. We had 12 total, so 12 minus 8 would be 4. So that, I guess we could argue maybe as being our second step in the process here, making this our third step if we want to make this easy to follow. We could draw an arrow to that place where we're putting that 4, makes it easy for people to see what's happening a little bit. And then we multiply those. 9 times 4 is 36. So they actually have the same areas as each other. And then once we get that, then we can just add those two together. So that we could call our fourth step, just adding those together, which would be 72 square centimeters. Good. If we look at number 7, city engineer plans to insert a stormwater drain within a public garden space. The green garden space or gray garden space, depending on your color scheme, will be filled with rocks and plants that help to purify the water. What is the area of the space that would be filled with plants and rocks? Alright, so again, it's either the green or gray space here that we're trying to fill. This one, kind of like we talked about before, is kind of like our donut. In this case, we've got kind of a square donut happening here. So we could think about, like we did before, finding the total and then taking out that middle part, right? Okay, so for the total, we've got a rectangle or a square specifically here. So we could just multiply our length times width. So 15 times 15. Remember, if you're multiplying this by hand, make sure you do your place value 0. So this would be 225. So if we didn't have a little piece out of the middle of this thing, our area would be 225 square meters. We do have that middle piece that's being pulled out of here though. So that's another rectangle. We could do 6 times 5, which is 30. And then in this case, we're actually subtracting that middle piece. So 225 total minus the 30 in the middle would be 195. Good. So 195 square meters would be the area of our space here. Number 8, Mrs. Villa needs to buy grass seed for her yard. She drew a diagram of her yard. Each square represents 1 square yard. Five pounds of seed is enough to plant 100 square yards of grass. Grass seed is sold in 2-pound bags. How many bags of grass seed does Mrs. Villa need? Alright, so this is obviously going to take us more than one step in order to figure this out. So first thing is going to be on splitting up the picture into different pieces. So the first thing, if we split this horizontally, we can split this up into 2 rectangles, or potentially square and a rectangle. So for our first one, if we count our squares, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it is indeed a square. So we multiply 6 times 6 is 36 is our first area. Our second area, if we count 1, 2, 3, 4, 1, 2, 3, 4, 5, we can multiply 5 times 4,
20.
Which is 20. And then if we add these together, the 36 plus the 20,
56.
we will get
56.
56 square yards for our area. So now that we know what our area is, now we can start looking at the seed part of things. So if we look at this, there was 100 square yards with a 5-pound bag. So if we take 100 divided by 5, that tells us that basically for every pound of seed we have, that would cover 20 square yards. Once we know that 1 pound would cover 20 square yards, then we could figure out how many pounds we need. So 56 divided by 20, we would get 2 16/20 pounds that we need. These are sold in 2-pound bags. I don't think they're going to make an exception for us here. And so in that case, we would need 2 bags. 2 bags would be 4 pounds, which would be plenty. But we'll just put a little bit of extra grass seed on it, and we should be in good shape. So this gives you an idea of finding areas of polygons, and what we're going to do on page 409, numbers 6 through 14 and 17.